Hello everyone, welcome to Unshackling Sudokus and Puzzles. I'm here to solve a Sudoku created by rockratzero and it is titled Dreidels and Gelt. I hope I'm pronouncing it right. I think it may be a German word, but I'm not entirely sure. I've solved the Sudoku already and I really enjoyed the solve. I first saw this in the Sudoku recommendation page of the CTC Discord server and it looked really tempting, so I just gave this a try and I really enjoyed the solve. I hope you do too. The link to solve this is in the description of the video. Please do give it a try and come back and watch the video. Let's start the Sudoku now. This puzzle is a combination of four different variants, so please pay attention carefully. Each row, normal rules apply. Each column and 3 by 3 box in the grid has digits 1 to 9, no repetitions. So classic, apart from classic part, you have the Dutch whisper part. So all these, kind of ice cream like shapes with a stick, purple stick. The orange lines are all German whisper lines. I'm sorry, they are Dutch whisper lines, meaning the adjacent digits on a Dutch whisper line will differ by at least 4. Then you have these purple sticks here in all the shapes. These are all Renban lines and digits must be consecutive. Then you have the killer part, the third variant in the Sudoku. Digits in cages must sum to the clue given in the top left corner. Then finally you have the quads. Digits in circles, you can see that there is a 1 in here and it is encompassing 4 cells. These digits must appear at least once on the 4 surrounding cells. So for example, if you see the 6 must be at least once in these 4 cells. So these are the rules. With that, we'll start the Sudoku. I'll take you through the exact solve path. So you have an 8 with 3 cell cage, so definitely a 1 must be inside. And you also have a 1 in these 4 cells, so which means in column 3, 1 must be restricted to these 2 cells. Let's do a little bit of killer stuff. A 7 is here, so which means that 13 is 4 plus 9 or a 5 plus 8. And similarly, this 14 cage here, it's 5 plus 9 or 6 plus 8. Okay, now we are about to address the crux of this Sudoku. So in a German whisper, and this time I'm saying it right, in a German whisper, the adjacent digits differ by at least 5. So which means if you have a low digit, the successive cell, I mean the adjacent cell, will always be a high digit. For example, you take a 1. And by low and high digits, I mean low digits are 1, 2, 3, 4 and high digits are 6, 7, 8 and 9, right? So in a German whisper, the digits always alternate between low and high digits. But in a Dutch whisper, because the difference is only 4, you have a kind of a problematic situation, you can say, but still one can conclude that only when it is 5, the digits don't alternate between high and low. That you can say, because for example, if you have a 5 here, you could have a 1 and you cannot say that because 5 is not a high or a low digit, it's just in between. So this pattern doesn't hold true here. However, if you take any other digit except 5, you have, let's say, 2, you will always have a high digit here, 6, 7, 8 and 9, and a high digit here, 6, 7, 8 and 9. Because to have a difference of 4, these two will always be high. So any other digit apart from 5 will always follow the high-low pattern. I hope I'm making myself clear here, right? Let's do with one more example. Let's say we have a 3 here. Then both of these cells, in order to have a difference of 4 at least, must be 7, 8, 9. So you can see that this is from the low group, 1, 2, 3, 4, and this is from the high group, 6, 7, 8, 9. So that is always followed when you don't have a 5. So now that we have established that, look at this shape. 1, 2, 3, 4, 5. There are exactly 5 cells in it. Now I'm going to ask myself, can this shape survive without a 5 in it? We have established that if there is no 5 on the Dutch whisper, the digits always alternate between high and low. So let's say this is a low digit. Doesn't matter, it can be high also. Let's say this is a high digit. So definitely this will be low, this will be high, this will be low, and this will be high. But now look at these two cells. They are from the same group. And we started out with high, I think. So this can be 6, 7, 8, 9, and this can be 6, 7, 8, 9. But how are you going to create a difference of 4? If two adjacent digits are from the same group, then there is no way you can establish a difference of 4, right? So what we have proved from this little exercise is that a 5 must definitely be inside that Dutch whisper. And not only this shape, in all the shapes that you see, because they are exactly 5 in length, a 5 must be definitely there, because if you don't have 5, then you're going to have an issue of digits from the same group adjacent, and that won't have a difference of 5. This is most fundamental step in the Sudoku, you can say. So now, where can the 5 be in this shape? We know that a 5 must be there. Now, if you have a 5, the adjacent digits will always be 1 and 9 in order to have a difference of 4, at least 4. Now, that means that 1 is also in this group. So 1 cannot be here. So 1 has to be here. And now, since 5 has to take a 1 and a 9, that puts the 5 either here or here. And 5 if it's here, 9 goes here. And 5 if it's here, 9 goes here. So 9 must be in one of these two cells. Okay, let's give a deep thing here. Can we do some Sudoku stuff here? Okay. I have another interesting deduction. Where does the 8 go in this box? Now 8 cannot be here, because then 8, 9 will be adjacent and there is no difference of 4. 8 cannot be in these purple cells, because then it will need a 7 or a 9, both of which are ruled out, because this is a Renban stick and you can't have successive digits if there is an 8 here. So which means 8 must be here or in these 3 cells, but 8 cannot be in this cell, because these two add up to 8. So which means 8 cannot be here and 8 cannot be here. So just these 2 cells can take an 8. Those form a pair now. Okay, and regardless of whether the 8 goes here or here, there will always be a 2, 3, 4 here. So this will be 2, 3, 4 and 9. Okay, that's nice. Now where does the 6 go in this box? 6 cannot be in the purple stick, because it requires a 5 or a 7 and both are ruled out. So 6 is forced into this cell. And that forces 2 in here because of the killer cage. This is not a 2, 3, 4, 9. And now the 2 goes in this Renban, which means it must be 2, 3. Beautiful, right? What a lovely sequence of logic, guys. Amazing. It's just gorgeous to solve such Sudokus. I really enjoyed it. So 3 is here. This means 3 is eliminated here. Okay, now this part needs to take a 2 for the quadruple. That means 2 is here. 3 is here. Now look at this 8 cage. It is 1, 2, 5 or 1, 3, 4. If it is 1, 2, 5, 2 must go in this cell and this will be 1, 5. And if it is 1, 3, 4, 4 must go in this cell and this must be 1, 3. So in either case, 1 is in one of these 2 cells. And that removes 1 from that cell. That is interesting. Now we have established that 5 must be in these sticks, because if not, we are in for a problem. And 5 can be eliminated here because that will force 1 9 here, but 1 is not possible in either cell. I is ruled out here. Okay, the next step I deduced was eliminating 1 from this cell. Now imagine that a 1 is here. Now these 5s will face an issue if the 1 is here, because if 5 goes here, these two cells will be 1 9, so 5 is ruled out here. And if 5 goes here, these two cells will be 1 9, so 5 is ruled out. And similarly this is also ruled out. So if 5 is here, you have a possibility. For example, this could be 9 and this could be 9, but very soon that hits a contradiction, right? And 9 will require a 3 or a 4 or a 5, but 5 is already here. And similarly this 9 will be a 3 or a 4. Now these two cells have an issue, right? So which means a 1 can never be in this cell. So 1 has to be here. That is really interesting. Now due to the same reason, 5 can't go here, because if you have 5 here, 1 is removed from both of these cells, so this will be 9, this will be 9. Now look what this is forced as. This is again forced as a 5. So 5 is not here. 5 goes here or 5 goes here. So which means 9 goes here or 9 goes here, depending on where the 5 goes. Now look what happens. Because 9 is in one of these two cells, you can never have a 9 in here, because that is seeing both of those cells. Awesome, right? Really gorgeous logic, guys. I mean, not only is the design extremely aesthetic, you can see all these ice cream sticks really aesthetic looking, and also the givens to 1 2 3 4 5 6 7 8, awesome. And this step particularly takes the cherry, you can say. So this is not a 4 9, so it's 5 8, because 9 cannot be there, and that removes 5 from these two cells. So 1 3 and 4. All right, so we are making some steady progress here. Okay, so now 5 is in here, so 5 gets eliminated here. That is a 5 now, which gives a 9 here. Now 2 is forced in here by Sudoku, and that forces 7 in here by Sudoku, and a 6 here. Now this is a Renban, so this means that would be 6 or 8, but you have an 8 here, pointing pair of 8, so that's a 6, which means 7 completes the column, and this has to be 8 which finishes off the column. These would be 3 4 and 9, and 9 will take a 3 or a 4 because of the German whisper, and now you can't have 3 4 here because that would violate the Dutch whisper. 9, and that's 3 4. That's excellent. What do we do next? So we can try to make use of these 13 cage. Now it's time to move the solve towards the right of the grid. Look at this 7 clue here. So 7 is removed here, so which means 7 is here, and by classic Sudoku rules 7 is forced in here. But notice that this is a 13 cell cage, and a 7 there means we need 6 more, which cannot be 1 plus 5, just 2 plus 4. 2 4 7. That is nice. And these cells are 3 5 and 6. To complete the row, that puts an 8 here in one of these two cells. Okay, for this quadruple 6 can't be here, so 6 is here. That's a 3 or a 5 now, which means this would be a 2 or a 4, because if it's 3 it's 2 or 4, and if it's 5 it's 4 or 6, so it's 2 or 4, and 2 is ruled out, so that's a 4. which means by Sudoku this is 3, this is 4. And look at this quadruple here, 5 has to be in here. And 4 has to be in these 4 cells, so 4 is not here. It's nice. So 6 is looking at these cells, so it's 5, 9. Okay. Remember that this part also takes a 5. Every candy stick will take a 5 because there are exactly 5 cells in it, an odd number of cells. The moment you have an odd number of cells, you will always have a 5 in it, because otherwise the parity will go for a hit. Especially when it's a closed loop, you can never tally the high-low parity without the 5 in it. 5 is in here, so 5 is in these 3 cells. Okay, and 5 can be removed from this cell because that will force 1, 9 here. That's not a 5. So regardless of whether the 5 goes in either of these cells, this will always be a 1 or a 9. And 5 is not in these 2 cells by Sudoku, which means these 3 cells will take a 5. Just thinking here. Okay, this also takes a 5 somewhere, right? Okay, remember this part, that is more easy to explain. You can't have 5 in here, which means 5 must be in these 3 cells. So this cannot be 5. So 3, that's a 5. And now this becomes a 1, 9 pair. Easy. So this will be 6, 8, and this will be 5, 6, 8 to complete the row. Now these 3 are 1, 3, 9. And you can't have 1 and 3 successive. So this is not a 9. It's 1 or 3, and 9 goes in one of these 2 cells. These will be 2, 7, 8 just by Sudoku. Can't have 8 here. Can't have 7 here because 7 is in one of these 2 cells. So this is 2 or 8, which means this is 7 or 1 just by the killer rule. So that's not a 7. So that's 1, that's 8, 2, 7. Excellent. Let me remove that. Place a 2, 7. And 1 here gives me a 9 and a 1. Okay. And by Sudoku, 1 must be in one of these 2 cells. Okay, now look where the 5s can go. 5s are really limited because of this 1 defined in here. 5 can't be here. 5 can't be here because these 2 will be forced as 1, 9. 5 is removed here, so 5 has exactly 1 cell. And that forces this to be 9. So which means this will be 3 or a 4 by touch whisper. And this will be a high digit. 6, 7, 8, 9, 7 or 8. And 7 is also ruled out, so that's 8. And now by Sudoku, 8 goes here. And that resolves this 8 and 5, which instantly resolves this 9 and 4. And so everything is being set properly. And that 9 here resolves this 5 and 9. Okay. Now we can make use of this killer part to get through the final portion of the grid. 14 plus 14 is 28. 28 plus 8 is 36. And you know that in any box there will always be a total of 45. Sum of the digits from 1 to 9. So these 3 cells will add up to 9 now. It cannot be 1, 2, 6 because 2 and 6 are both in the same row and you cannot fit 1, 2, 6 here. It cannot be 1, 3, 5. So it is 2, 3, 4. That's nice. and which means 4 is ruled out here. So that's a 4, that's a 2, 3, and that resolves that part. 2 and 7. So these will be 1, 6, 7. You can't have 1 here, so that's 1. And 7 in here gives us 6, 7. So let's finish up this column. 2. 5 here gives a 5 and 8. And let's finish up this column. 3, 4, 7. 7 goes here. 3 and 4. This will be a 6. And the Renban part is satisfied. Okay. And 2 here gives 3 and 2. So let's quickly write in the digits here. This is 2, 3, 5. 4, 6 and 8. 1, 3, 9, 2, 5, 7. So 4, 6 and 8. And in order to have a difference of 4 here, it has to be 4, 8. 6 goes there. That gives 8 here. This will be 7 or 9 by Renban. 1, 7, 9 and 1, 7, 9. Excellent. This is a 5, 6. And remember that an odd number of cells in a closed loop of Dutch whisper will always have a 5. There's only one cell left, so this will be a 5. This is 6. That's a 1, 9 pair now because of the 5. So that is a 7. It's not a 7. Okay. Getting closer now. Okay, can we look at this cell? Seven in row 2 must be in one of these two cells. A 7 here forces 2 here. So 7 goes here and that forces 7 in here. So this will be now, you can't take a 9 here because this is a 9 cell cage. So 9 in row 2 is forced here. That forces 9 in here. 1 and 3. And that forces 9 here, a 1 here. This will be 1, 3, 4. Which means this is 8, 6 or 5. 5 is ruled out. 6 is ruled out. So that is 8. This is 1, 3, 1, 4, 3, 3, 6, and that is instantly reduced. Oops, 3 and 6. And if you look at this column, okay, you have a cage, unfilled cage here. That's a 5. This is a 2, 3. And 1 here gives a 1, a 3, a 3, a 2, an 8, a 4. This is 5, 2 and 4. Okay, so you have an uniqueness issue here, but that is cutely resolved because of this candy stick. So 2 here, 4 here, 4 here, and 2 here. And with that, we have completed this really gorgeous Sudoku by rockratzero. What a fun and tremendous solve this was. I do hope that you enjoyed this Sudoku as much as I did. Please do let us know your thoughts in the comments below. We'll see you soon again with the video. Bye-bye.